Alright everyone, welcome to viewing Evan Pick and Ryan Mayall's SCADA6100 course final project. So throughout this course we've been working on a project for an asphalt plant to implement in a SCADA system inside. The purpose behind choosing a asphalt plant to use as our SCADA project was because there were two reasons. Ryan had background in the cocoa paving placement for an asphalt plant, and as well as I was interested in applying for the cocoa paving job that was posted. And I was thinking of possibly using this for almost like a portfolio to show that I can kind of see what I'm talking about with the process and making asphalt products, and as well as implementing a SCADA system and running multiple controllers at once and getting figurative tasks done in this project. And we started off with implementing thick clients, and then to the thin client, and then to the mobile client. And this video here showcases our thin client with all our screens and our mobile client with our mobile screens and viewing all the other screens and controlling from a smart device. So let's get into it here. So as you can see here at the beginning, I, myself, Evan, use my username and my password, and I log into our thin client. So I'll punch that in right now. Alrighty, there's the password, and I'll log on. Now this screen here that displays first is our dashboard. Our dashboard shows all the key information for each area. So I have area 1 with the CLX controller, area 2 is the CLX, area 3 is our SLC, area 4 is our Micrologix RTU. And as you can see, the gauge doesn't show up on area 2, but at the same time, the trend for the area 1 control shows up, and the bar graphs for area 3 show up. So this is our process overview. We have a login and logout user button for when we were using our thick client. They don't work in the thin client. We use that log off button right there. And as you can see, I logged off and it logged me off. So I'll go back in and punch in my credentials. Then I'll click login and we're back on the dashboard because that's the initial display. And you can see the status of all 4 areas. They're all running because they were all green. So let's go to the cold feed conveyor. Now my user group has all read and write access on every display. So I'll show you how it works. So it says the drive's running right now at a speed of 70 Hertz. And we can stop it and it goes back down to 0 on the trend. And the drive indicator running light has stopped. Now if I start manual mode and press VFD forward, it's going to just momentarily run the belt forward or momentarily run the belt reverse. And then, as you can see on the graph here, when it goes reverse, it goes into the negative RPMs. And as I started the auto mode there, the drive indicator running started, and it started back at a frequency in reverse of 70 Hertz because that was the last command pressed. So I go back into manual, trigger it to forward, manual mode stop, auto mode start, and the drive goes back forward at a speed of 70 Hertz. And this here is where we can enter in a new commanded frequency for the PowerFlex 70. So as you can see, I changed it from 70 to 55 Hertz. It changed on our commanded frequency, and it changed all the stats, and the trend's dropping. So I went down to 20 Hertz. The trend goes from 70 to 55 to 20, and I stop it, and the trend plummets to 0. So next, let's go back to process overview. And as you can see, I shut off the auto mode, so that indicator is now indicating off. Let's go into the mixing drum next. So on the mixing drum here, you can see we have our trend with our waveforms, a start data log and stop data log button, start mixing and stop mixing. And when stop mixing is pressed, the indicator goes off. We have a nice graphic that accurately shows what the process would look like. So as you can see, I press start. The mixing drum status went back to active. Materials and drum is showcased above. Mixing drum temperature in degrees Celsius is showcased. Drum unload speed in feet per minute and drum speed and RPM are also displayed. Labels indicating which area is coming from what, so it comes in from the cold feed conveyor and out to the storage silo. I still have all my navigation buttons in the top left. I also still have the ineffective login and log out buttons for the thick client. So the start data log will, when that is pressed, all values will be logged to a data log using a Microsoft SQL server. And when stop is pressed, it's pretty self-explanatory. This is back to our dashboard. So as you can see, you have area 1, area 2, all of the PLC statuses, and the silo conveyor RPM, silo percent full RPM, bar graphs. There is a gauge here that works in the thick client that does not work in the thin. Next, we're going to go to the storage silo. And going to the storage silo, we have a start conveyor and stop conveyor PB. We have an indicator indicating that this belt is running. We also have a trend that is a linear trend that shows that a steady amount of material is being loaded into the silo. The belt's running at a continuous speed. The silo percent is slowly increasing. The hot oil RTU is next. So this is the RTU featured in cell 9 of the IMC. So we have a system on and off. System on, pump running indicator. It's off right now because the tank's draining. An empty valve active, so that valve's open, it's draining. Low level indicator came on because it reached a low level. Manual mode is not selected, auto mode selected. The pump's running, it's filling up the tank. The high level indicator comes on. When that comes on, the pump stops running. And that drains again, repeating itself. So next, let's go to the mobile dashboard. So this is a resized dashboard, conveniently resized for smart devices. It was designed with the Samsung tablets used in the lab in mind. And the auto mode start, so we get that running again. Punch in a speed of 70 Hertz. Just to get it back up to speed. Go back to the mobile, and as you can see here, the cold feed conveyor indicators back to being active, the PLC is in remote run, and then every other one except our SLC was stuck in remote program, as we could imagine that it'd be down for maintenance or something, but it still executes as needed. So I'm going to log in with the Bo username that I created under the evaluation user group. Same password as everything else, but this is just to show that there is only write access to the area 1 display and everything else cannot be written to. So as you can see on area 1 here, I can punch in a value of 65 Hertz, run the VFD reverse, press the auto start PB. It's going 65 Hertz backwards. Change it down to 20. Everything will change to 20 here. Or rotor speed will go down to 564. Go back to the mixing drum. And as you can see, I am clicking the button here to try and stop the mixing drum, but it's not allowing me to. Same with the stop conveyor PB on the storage silo. So this portion here is showing the mobile thin client. And as you can see, the device I'm using is an Apple iPhone. This is my personal phone. So I'm punching in, I'm screen recording off my device here, but I'm punching in the URL for our mobile thin client while I'm logged into the IMC SCADA Wi-Fi network, the network that the server is live on. So I punch that in, it loads Factory Talk Viewpoint, and it pulls up a login screen. So I punch in with my credentials. And remember, I have access to read and write on every display. So I click on Dashboard Mobile. It brings up the mobile dashboard. So I zoomed out a little bit just to show that, or zoomed in a little bit just to show that you don't have to pinch it to see everything. Turning the screen or landscape does require you to pan through, not really pinch through to see everything, but it does make the trends bigger. This mobile display was designed for a Samsung Galaxy tablet, but I didn't have access to that at the time. I just had my phone on me. So as you can see, I'm on the area 1 display for the cold feed conveyor. I'm controlling the VFD. Through here, I'm punching in a new speed of 70 hertz, going up from 20. It's hard to see the trend as it's scaled to your device screen, but everything else there is still able to be viewed easily.
The job posting that Evan and I came across that implemented SCADA into the job position was a company called Delco Automation Incorporated, and the job position is called PLC HMI Programmer / System Integrator. Just in the description of the job, they were looking for someone with technical expertise with many certain softwares. But the main one that we're going to focus on is they wanted someone with technical expertise in SCADA. The way we believe SCADA would be implemented into this job position is they're looking for someone who performs proper planning studies, followed by proper detailed design, manufacturing, and things like that. So the way that SCADA that we learned in the course could be implemented into the planning studies and followed by detailed design is just organizing where in the certain job that you are working on, where you would have to implement these certain components of the system. You want to make sure that it's all planned accordingly and very neat. You do not want to have everything all bunched up onto one screen. You want to be able to make it very accessible to the operator on different screens, and making sure that it's a detailed design, but it's not too cluttered for the operator to look at. So that's just one thing that we've learned in SCADA, is just making sure that it's not too much for the operator to look at, and make sure it's very easy to understand. This job position also integrates SCADA into this role due to the fact that they want someone who can take the responsibility for any size of automation or security project. So with that, it would just be being able to implement a huge facility, such as a water treatment plant, as they've listed here. We would have to create separate screens for separate components of this entire treatment plant, and making sure that it's understandable for the operator to understand, and making sure that it's on the correct screen or they can access that screen type of thing. We would also integrate security into the SCADA system using user groups, which we learned in the SCADA course. So we would create user groups for everyone who can access the screen, create their username, password, and then within these user groups we would create security codes for the screens and or buttons. So with creating user groups and then putting security codes assigned to the user groups, it would allow access for certain user groups to see certain screens, and then also operate certain buttons on the screens. So yeah, we would implement the security through our SCADA with the thin and thick client. They also want program development and testing. So with creating the SCADA program, we would also want to be testing to make sure that everything is working, the RTUs connecting, conveyors are moving, whatever the project is. We want to make sure that what we are implementing into our SCADA is being able to operate as we've created it with our software and logic within other programs. So we can check that by using graphs, and then obviously just making sure that everything is working accordingly. And below right here, they want someone with programming experience with more of the following platforms. We have used Allen Bradley for all the programming in SCADA. So we're very, very familiar on how to program the SCADA and then implement SCADA. We've used a lot of Allen Bradley with programming, compact logics, and the SLCs. So then we would then implement our SCADA with these softwares. And we also used SCADA. We used Rockwell Automation, and we used FactoryTalk View SE. So we'd be very familiar with just one of the softwares they want us to know about when implementing SCADA and the HMIs.